Hello guys, today we are going to see about leaf procedure concept in MIPS. So, what is procedure first of all? Procedure means a function. A function is used for reusable code. So we can call the function any number of times, correct now? So for the function, how to write the assembly code? So that's what we are going to see now. There are two types. One is leaf procedure and non-leaf procedure. So today we are going to see only leaf procedure. Leaf procedure means in the function and within the function do not call any other functions are called leaf procedure. Non-leaf procedure means within the function, a function can call another function, then it is non-leaf procedure. The name itself says leaf. A leaf means, here you can see that this is the leaf, so this is the branch, correct now? So leaf means after that there is no further branches, that's why it's leaf procedure. The name itself says, that's why here says procedure do not call other, means do not call other functions are called leaf procedures. So before we are going to write assembly code for this assembly code for the C code, we are going to see some important registers. Okay, these are all the important registers. So A0 to A0 to A3 is inbuilt registers for arguments, function arguments. For return values, there are two registers, V0 and V1. So we can return two values, and there are 10 temporary registers and 8 saved registers, and then global pointer. The global pointer for static data. In programming, you may include static. So the static is belongs to class now. So for example, static in data, you assume some value. So the static data is accessed in anywhere. Same like in globally, you declare any variable like num equal to 10, something like that. So it's a global variable. For this we use global pointer, and then stack pointer. Stack pointer points to the top of the stack, means this is the top of the stack, so the register points to the top of the stack. And then frame pointer. The frame pointer means it's the base, it points to the base address of the stack of the pointer. It's the frame pointer. And the return address. Return address holds the address of the next instruction. In procedure call instructions, means in procedure call, if it is jump and link, the jump and link means it is jump and a link the address of the next instruction. It is used for non-leaf procedure. So now we are not going to see that. We are going to see about leaf procedure. For leaf procedure, it is procedure return, means jump register. So jump the register to the next programming counter. So here you can see JR RA register. JR means jump registers. RA contains the address of the next instructions. So RA register address is copied to program counter. So the program counter is used for fetch the address of the next instruction. So the program continuously fetches the next instructions. Okay, now we are going to solve the now we are going to write the MIPS code for the following C code. The C code has 4 arguments. I think here int will come. I think here also. There is one f is declared, and g plus h minus I plus j is function operation, and the operation is stored in, and the result value is stored in f, and we return the value of f. So the arguments start from g to j. Here that g to j are stored in argument registers, and the f is in s0. F must be stored in s0. So they said, so we need to save the s0 value on the stack, because the s0 may have a important value. So we need it future, we need it later. So we need to store it in on the stack, and later we can't get it the value. That's why we use stack. And the result value is stored in v0 because we only return one value. So $v0 register is used. And another important thing is the stack pointer always grows down. So it's because to make the efficient use of memory, because the heap memory grows up and the stack memory grows down. So the in between space is free space, and this free space is used dynamically by the any other program. That's why. Now we are going to see how the MIPS code is generated. So first of all, the leaf example means the function name. It's like a label, and then we immediately add -12 because we want to compute g plus h, and we want to store in temporary variable, and we want to compute I plus j, we want to store it in another temporary variable, and we want to subtract each of them. So that's why. So we need 3 registers, T0, T1 and S0 for F. So we need to save these register values in stack before we going to compute the operations, because these register may have an important value. So these registers value may be used for later. So we are going to save the values in stack. For that, the stack is added immediately with the -12 because we need 3 registers. 3 into 4 means -12. For example, if the base address of the stack is 10,000, so the -4 is deducted, then it is 996 and 992 and 988. This is how it looks. After that, so in these pointers, in this position, in 996 position, so the value of T1 is stored. In 992 position, the value of T0 value is stored. In 998 position, the value of S0 value is stored, something like that. So now the main operations, G plus H. So the G plus H, so G is first argument, so the 0th argument, and H is the first argument. So we add both the register and the result is stored in T0. Same like I plus j, we add the both arguments A2 and A3 and the result is stored in T1. And finally we subtract the both temporary registers, so the resultant value is stored in S0. So we want to store the resultant value in V0, right? For that, if you want to store the registers value from another register, we add 0, right? That's what it is done. And then we again store the value of the registers back to their registers. For that, we again load the value from the stack, and it is again loaded in the corresponding registers. We can see like that. And the stack pointer is set to base address because it is initially 998 now. So the stack pointer points to 998. After +2, it points to the initial base address 10,000. After that, we say jump register. We return the address of the next instruction. So the next instruction the address of the next instruction copies to the program counter, and the instruction is fetched. So this is leaf procedure concept. This is how the MIPS code is. This is how the C code is converted into MIPS code.